Hello my dear students, welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today we are going to solve some numericals based on Bohr atomic model. We have derived the radius of orbit, the energy of electron in the specific orbit, the velocity of electron in specific orbit. So today we are going to solve some numericals on the basis of that formulas that we have derived in the previous lectures. So the first numerical is saying calculate the radius of Bohr's third orbit in lithium-2 positive ion. That's my first numerical. First of all, specify your orbit number. In any question, first of all, always specify the given things in the question, and in this case, first of all, I'm specifying the orbit number. My orbit number, the n, comes out to be the 3. Now let's talk about the atomic number. Is lithium 2 positive ion. Lithium, what's the atomic number of lithium? That's also 3. So we have to evaluate the radius of Bohr's third orbit. So what was the formula for the radius? The radius of nth orbit, is equal to the 0.529 n square by z. The units of radius according to this formula is angstroms, is 0.529 n square by z angstrom. So now let's substitute the value of n and z over here. It comes out to be 0.529 was n over here is 3. So it's 3 square divided by what's the atomic number? It's again 3, comes out to be 3, and this value comes out to be 1.587 angstrom. So the radius of third orbit of lithium-2 positive ion comes out to be 1.587 angstrom. So it was a very easy question. So let's move to the next question. Now the second question. The second question is asking calculate the velocity of electron placed in the third orbit of hydrogen atom. Here the orbit number, the n, here n is 3. Hydrogen atom, the atomic number of hydrogen atom is 1. So we have to first of all evaluate the velocity. What's the velocity in the Bohr atomic model? What's the formula for the velocity? It's 2.18 into 10 raised to power 6 into z divided by n, and this units is meters per second. So the velocity of third orbit for hydrogen atom will be 2.18 into 10 raised to power 6, what's z over here is 1, divided by n, what's n over here is 3. So this answer comes out to be 0.726 into 10 raised to power 6 meters per second. So that's the velocity of electron in the third orbit of hydrogen atom. The next part, the question second part is saying calculate the frequency of revolution of electron. So what was the formula for the frequency? The frequency of revolution is equal to the v by velocity by 2 pi r. We have evaluated the velocity, but we don't know the radius of third orbit. So for calculating the frequency, we need the radius of third orbit also. So let's calculate the radius for third orbit. The radius for third orbit, first of all formula, the radius of nth orbit is 0.529 n square by z, and this in angstroms. This thing comes out to be 0.529. Was the orbit number over here is 3. So it's 3 square divided by what's the atomic number over here is 1. So the radius of third orbit comes out to be 4.761 angstroms. Now carefully observe that The velocity, the unit of velocity is meter per second, so we need to convert our radius also in meters. So it comes out to be 4.761 into 10 to the power minus 10 meters. So now let's calculate the frequency. Now I'm coming back to frequency. Now frequency was the velocity of electron in third orbit is 0.729 into 10 to the power 6. I have just substituted this value of velocity over here. It's 0.726, sorry, it's 0.726 into 10 to the power 6. Now it's divided by 2 pi r. Is 2 was the value of pi is 3.14. Now let's substitute the value of radius over here. So what's the value of radius over here is 4.761 into 10 raised to power minus 10. So the frequency, the number of revolutions per second, comes out to be 2.42 into 10 raised to the power 14. So that's the number of revolutions per second, or you can say the frequency. It comes out to be 2.42 to 10 to the power 14. So that was the second numerical. For evaluating the frequency, the formula was velocity divided by 2 pi r. I have substituted the value of velocity which we have calculated over here, the velocity of third orbit, and its velocity divided by 2 pi r. Firstly, we have evaluated the radius of third orbit, and then I have substituted that value in 2 pi r in r, so you got the frequency to be 2.42 to 10 to the power 14. So that was the second numerical. So now let's move to the third numerical. Now the third numerical. Third numerical is asking, calculate the velocity of an electron in Bohr's first orbit of hydrogen atom. Now again let's write down the given thing in the question. The first orbit means my n is 1. Hydrogen atom means my atomic number is also 1. We have to evaluate the velocity. What's the formula? Velocity of electron in nth orbit is 2.18 into 10 raised to power 6 into z by n, and the units are meters per second. Let's come back to the previous question, please. I forgot to write down the units of frequency. Is 2.42 10 to the power 14 per second. So now let's come back to the next numerical. Now we have to evaluate the velocity of electron in first orbit. So it comes out to be 2.18 into 10 raised to power 6. What's the value of z is 1, divided by what's the value of n, that's orbit number, it also comes out to be 1. So velocity of electron in first orbit comes out to be 2.18 into 10 raised to power 6 meters per second. So now let's move to the fourth numerical. Now fourth numerical, he is saying calculate the radius, velocity, frequency and time period of electron in fourth orbit of boron atom. First of all, write down we are writing the given thing in the question. The orbit number comes out to be 4. The atomic number of boron is 5. So now first of all let's calculate the radius. So the radius, the formula is the radius of nth orbit is 0.529 into n square by z, is in angstroms. So the radius of fourth orbit comes out to be 0.529 into n square. What's n over here is 4 square divided by z. The atomic number is 5, that's z, and this answer comes out to be 1.69 angstroms, or simply you can write 1.69 into 10 to the power minus 10 meters. So this was the first part of the question. We have just evaluated the radius. Now let's talk about the velocity. What's the formula for velocity of electron in nth orbit? It comes out to be 2.18 into 10 to the power 6 into z divided by n, and it's in meters per second. So this thing comes out to be 2.18 into 10 to the power 6. What's z over here? The atomic number. The atomic number of boron was 5, and we have to evaluate the velocity of electron in the fourth orbit. So it comes out to be 4 over here. So this thing comes out to be 2.725 into 10 to the power 6 meters per second. So now let's talk about the frequency of revolution. So now let's talk about the frequency of revolution. What's the formula? It's velocity divided by 2 pi r. So let's substitute the value of velocity from the previous part, velocity of electron in fourth orbit. I'm substituting the value, that's 2.725 into 10 to the power 6 divided by 2, pi is 3.14. And now let's substitute the value of radius that we have evaluated in the first part. It comes out to be, the radius of fourth orbit comes out to be 1.69 into 10 to the minus 10 meter. I'm substituting this value is 1.69 into 10 to the power minus 10. So from here you will get the frequency to be 2.56 into 10 raised to power 16 per second. So these are the number of revolutions made by electron per second around the nucleus. So that was also the frequency we have evaluated. Now let's talk about the time period of revolution. Time period of revolution stands for in how much time the electron is completing one revolution around the nucleus. So the time period of the revolution will be equal to 1 divided by frequency, the inverse of frequency. So it comes out to be 1 divided by 2.56 into 10 raised to the power 16. So the time period of revolution comes out to be 0.4 into 10 to the power minus 16 seconds. So this for the time is 0.4 into 10 to the minus 16 second for one revolution of electron around the nucleus. So that's all for today. So these were the numericals based on the Bohr atomic model. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.